I bet if you just asked someone if they knew what the area formula was for an area of a triangle, they would tell you that the area is equal to 1/2 the base times the height. And oftentimes, many people just think that's the only formula we have for an area of a triangle. But that area is used when we know the information about a triangle that is a given side and the height of the triangle off that side. There are many more formulas for finding the area of a triangle, and they're all dependent on what information that we have. Sure, sometimes we can do a lot of extra work in order to find the given information to fit it into one of these other areas, but there are formulas that let us directly go to the area of a triangle when we have other information besides just the base and the height. So if we have the base and the height, that is the formula that we're going to use. The area is equal to 1/2 the base times the height. But what if we know the three side lengths? Well, if we know the three side lengths, then we're going to actually move on to the formula for area of a triangle that gives us the area directly from the information of the three sides. So what we'll first do is we will take and we will calculate what's called the semi-perimeter. And the semi-perimeter is found by adding the three sides together and divide by 2. That's our value of S. And then our area is equal to the square root, and make a long square root, that numerical value S that we found, times the quantity S minus the side length A, multiplied to S minus the side length B, and then S minus the side length C, all under the radical. Will simplify, and that will give us an area of a triangle when we know the three sides. Well, what if instead of the three sides of a triangle, we know two sides and the included angle between those two sides? In that case, we'll use the formula area is equal to 1/2 the side length that we know times the other side length that we know times the trig function sine of the angle between them. Now remember, when you utilize that formula, you'll need to make sure that you have your calculator angle mode to be the correct mode for what angle you have, measurement you have for angle C. And usually it'll be degree measurement, so you want to make sure it's in degree mode. If we know 2 or 3 angles and just a side, then we'll use the formula that the area of a triangle is the side that we know squared times the sine of the angles that are not opposite that side. Multiply together and divide that by 2 times the sine of the angle that is opposite the side we know. And then the third one we're going to cover in this video is what if we know 3 points on the coordinate plane. So we have ordered pair points on the plane that 3 dots will connect to make a triangle. Well, in that case, we can use the formula for our triangle. The area is equal to, now this plus or minus in this formula is different than how we normally have it. Here it's not that we give both cases. It's that we choose the correct sign so that we multiply either a positive 1/2 or a negative 1/2 times what we get for this determinant to make sure that our area value is a positive number. So if the determinant comes out positive, it'll be a positive 1/2 that will multiply to it. If the determinant value comes out negative, we'll use a negative 1/2 so that negative times negative gives me back to a positive number. Now let's look at some examples, and I'm going to scroll through this, so we might need to come back and forth to find the formulas. So the first one is find the area of the right triangle with one leg of length 6 inches and the other leg of length 9 inches. So let's go ahead and draw our right triangle. And remember, the legs are the parts of the right triangle that are not the hypotenuse. So I have one length of side, one side of is 6 inches and the other leg is 9 inches. And so in this case, I do have the height of the triangle off the base that's 6 inches. So we're going to go ahead and use our formula that we're really familiar with for the area of a triangle. 1/2 the base, 6, times the height, 9. And as we multiply these together, it's multiply them as they occur from left to right. 1/2 times 6 is 3, and 3 times 9 is 27. And our area is square inches. Let's look at the next example. Here it wants us to find the area of a triangle with side lengths of 4 centimeters, 6 centimeters, and 8 centimeters. So here we have the 3 side lengths of the triangle. So for that one, we are going to use our formula that is Huron's formula. So remember, we're going to find the semi-perimeter first. So we will take and find S is equal to 4 plus 6 plus 8 divided by 2. So that gives me 10 plus 8 is 18 divided by 2, which is 9. And then our area is the square root of, and I'll rewrite it here, S times S minus A times S minus B times S minus C. So our A is equal to the square root of 9 times 9 minus the first side, 4. Then we're going to multiply that to 9 minus the second side, 6. And we're going to multiply that to 9 minus the third side, 8. Now let's go ahead and simplify this. It's the square root of 9 times 5 times 3 times 1. And this is all multiplication under the radical, so we can simplify this square root by bringing out any perfect square factors. So the square root of 9 is 3, but I don't have any other perfect square factors, and I'll just multiply together the remaining factors. 5 times 3 times 1 is 15. So I have 3 times the square root of 15 square units. They're centimeters, aren't they? So square centimeters. Next step, for example 3, find the area of the triangle with side A being 12, side B being 7, and angle C being 30 degrees. Well, I have two sides, and the angle that they give me is not the same letter as the two sides. So it's not opposite those sides, it's the angle between those two sides. And we're going to scroll back up and see which one we're going to use for that. And for that formula, when we know two sides and the included angle, area is 1/2 A times B times sine of the angle C. So we have our area is equal to 1/2 times 12 times 7 times the sine of 30 degrees. Checking to make sure your calculator is in degree mode and multiplying these together. Actually, let's go ahead and find the sine of 30 degrees first, and we'll write that in. Sine of 30 degrees, when you do that on your calculator, you will see 0.5, which is 1/2. And those of you that have studied trig a bit and know your unit circle and the trig functions of nice angles, you'll remember that sine of 30 degrees is indeed 1/2. Now we're going to multiply these as they occur from left to right. 1/2 times 12 is 6. 6 times 7 is 42, and 42 times a half is 21. So I have 21 square units. All right, then example 4. Find the area of the triangle with side A being 3 feet, angle A being 27 degrees, angle B equaling 63 degrees. Well, that's got a side and 2 angles. And so when I'm looking at that, once you know 2 angles, you can find the third angle by recalling that a triangle has 180 degrees. So we're going to take the total degree measure for a triangle, 180, and subtract the 2 angle measurements that we already know. And for this one, 180 minus 27 degrees minus 63 degrees gives me 90 degrees. So I have actually, as soon as I know 2 of the angles of the triangle, I automatically can get the third one. And coming back up to the area formula that involves 2 or 3 angles on a side, our area is equal to A squared sine B sine C over 2 sine A. And be careful about the duplicity of our lettering there, area on the left-hand side. Technically, I probably should have just written out the word area. So here we have our area is equal to A squared sine B sine C over 2 sine A. So our area is equal to 3 squared. Remember, that's small case lettering by convention is the side length, and capital lettering is the angle measure. So this is the sine of angle B, so 63 degrees. Sine of angle C, that's 90 degrees. And divide that by 2 times the sine of angle A, and angle A is 27 degrees. So 3 squared is 9. The sine of 63 degrees is about 0.8910. The sine of 90 degrees is 1. And in the denominator, I have 2 times the sine of 27 degrees is approximately 0.4540. So going through those calculations, we get that our area is approximately equal to 8.8317 square units, square feet. And then lastly for this video, we have find the area of the triangle formed by the 3 points 3, -4, 2, 0, and 5, 3. So with the 3 coordinate points, or 3 points on a coordinate plane, we're going to use something called determinants. And our area of our triangle is equal to plus or minus 1/2 times the determinant of. This means you're going to take the x coordinate, then the y coordinate, then the number 1 of your first point. Then for your second point, the x coordinate, the y coordinate, and then the number 1. And then for the third point, the x coordinate, the y coordinate, and the number 1. So we have our area is equal to whichever we need, the positive or negative, so that when we multiply it out, we get a positive value for our area. And each ordered pair has an x and a y. And we can put the subscripts above the ordered pairs so that we'll sneak this one underneath. Keep track. So in my first row, I have 3 leave a space, -4, leave a space, 1. Then in my second row, 2, 0, 1. And then in my third row, 5, 3, 1. Now with the determinants, we certainly could use our calculator to find the value. We could do a process called expansion by minors that works to find the determinant of any size square matrix. Specifically with the 3x3s. Don't try to do this with the larger dimension. You'll get a number, but it won't be the actual value for the determinant. But for the 3x3s, we can do something called the basket weave method. And what we do is we copy the first column again, and we copy the second column again. And we are going to find this value of the determinant by taking and multiplying down the diagonal. So go up in the upper left-hand corner and multiply the numbers down the diagonal. So we have 3 times 0 times 1, and then add to that -4 times 1 times 5, and add to that 1 times 2 times 3, and off of that we're going to subtract multiplying up the off diagonals. So we start in the lower left-hand corner and do the diagonals up. So 5 times 0 times 1 plus 3 times 1 times 3 and plus 1 times 2 times -4. So we're going to simplify inside both sets of parentheses and then carry out our subtraction. So we have 3 times 0 times 1 is 0. And then -4 times 1 times 5 is a -20. And then plus 1 times 2 times 3 is plus a 6. And then minus 5 times 0 times 1 is 0. Plus 3 times 1 times 3 is 9. And then a plus, but it's a 1 times 2 times -4, which is -8. That gives us a -14 minus a 1, which gives me a -15. So that determinant value is -15. Now notice that's a -15. So I need the -1/2 with the -15 to have a negative times a negative is a positive value. So my area is -1/2 times -15, positive 15/2. Or we can write that as 7.5. And here we just have square units. So you can see from these examples that there are many more formulas for areas of a triangle, and it's all dependent on what information you have about the triangle to which area formula you will use.